Okay, welcome back for another week. If you're quizzing or fixing a quiz, do that first. Just write that for your warm-up. That's fine. Quiz. Everyone else, we're going to do this warm-up in a second. On the way in, you should have grabbed one of these little pieces of paper. This is an opportunity for extra credit. I don't do extra credit a lot, so here's one of them. It is Red Ribbon Week, okay? And so like it says on here, let me pull this up. Okay, you can get extra credit if you can create a poster that supports a drug-free lifestyle. So this is pretty basic, okay? But I want this to be a little bit more creative. Has a little bit of math in it. So here we go. To get the extra credit, which will probably be points added onto your test average, which really helps your grade a lot. More than just like an assignment replacement. Okay. You want to get a large poster, so not just like a random piece of paper. I might have some like decent sized sheets of paper I could let you use. By the way, this is not like in class something we're doing. It's something you would do in if you have extra time in class or at home. But on a larger poster, you want to do something unique, creative, and colorful. Okay, so don't draw like a stick person in black and white and think that that's going to work. It's not. It has to look like you tried. Okay, so if you can make something colorful, creative, unique with pictures and drawings, and it must include a mathematical statistic that confirms the harmfulness of illicit or overusing of prescription drugs. Okay, so obviously not just like aspirin. Okay, obviously we're talking about stuff that's harmful to the body through overuse, addictive, etc., etc. Okay, that's what Red Ribbon Week is all about. Okay, promoting drug-free lifestyle. And the only way I can give you extra credit is if it has some relation to our subject matter. So math, that's easy. Okay, so what you're going to do is, unless you know exactly where to find something, you can Google it or search around for a website. But you need to include a statistic. Okay, it could be the percentage of people that are affected by it. How much of whatever drug that you would need to overdose, demographic percentages, if you overuse this drug, the percentage you'll end up homeless, harmed, whatever, just whatever it is. There's plenty of stuff out there. So all you got to do is, again, it has to be on a large poster, be colorful and creative. You have to include that statistic on there, and you have to include the website. Google is not the website. Google is how you get to the website, maybe, okay? But don't just put Google. That's not good enough. It has to have all four of these things by this Friday the 28th, no later, please, okay? So that's optional. Extra credit, you don't have to do it, but if you do, it can help your grade. Again, I don't do that very often, so it's up to you if you want to do that. So again, Red Ribbon Week this week. Now let's do this warm-up. All right. It says write an equation in root form. This is what we did the last couple days last week, right? Now, if I give you a graph, hopefully you could write it in root form. But even if you have a description, you should be able to figure out root form. So all we need to know is the A, and we need to know our roots, okay? So what is our A value? It says it's been reflected across the x-axis. Okay, so is everyone looking up here? Everybody look. Unless you're doing a quiz, you can look at your quiz, but finish. Okay, focus on that, please. Hey, are you quizzing? Okay, so again, A usually opens upward at some ratio, right? But if it's reflected across the x-axis, that means that now it is opening downwards. What kind of number is A going to be if it's reflected downwards? A negative, okay? A negative number will be our A. And it says that it's been vertically stretched by 2, so what is my A value going to be? Okay, so put those two together. If it's opening downward and it's stretched by 2, what? -2, okay? Do y'all see that? Reflecting is negative, stretching by 2 is 2, okay? So this is my A value that I'm going to put right here. And then what do we know about these insiders right here and right here? Insiders what? They lie, they're opposite, right? So you can put these numbers here, but just remember, insiders lie. They're going to be opposite positive, negative values, right? So let's go and write this equation. Y equals, what was my A value again over here? negative 2, and then what am I going to put inside the parentheses here? You start with the x and then plus 3 because it's opposite. Insiders lie, right? And then, what are you doing? And then on the other parentheses, x minus 5 because, again, insiders lie. So it's not positive 5, it's minus 5. Cool. All right, and that's how you can take a description and get an equation in root form, as long as you know the vertical rate of change, so to speak, and then the roots. All right, I'm going to pass out these notes. We're going to talk about transformations this week. Transformations of quadratics. Okay, so all right, here we go. So this is going to be similar to what we've been talking about last week with vertex form, talking about the a value. Okay, we talked about it on the warm-up today, but a is the number in front of the x squared, right? So whenever we have a graph, okay, we'll have a number up front, and we're going to talk about how does that affect it. Okay, so here we go. The quadratic parent function is x squared. Okay, so when you have a parent function, okay, it's very basic. Go ahead and write that down if you didn't already know this. Parent functions are basic because they go through the center at 0, 0. They're not stretched or compressed. They're not shifted any direction. They're just straight up in the center, basic. Okay. So x squared is my parent function. The axis of symmetry from the center is right at x equals 0, and the vertex is at 0, 0. So again, from now on, do you see that's the parent function? Just straight up x squared going through the origin. Okay. All right. Now, we're going to sketch some graphs on here. It's going to be rough sketches, but we can do it. All right. So first thing I want you to do is just go ahead and draw yourself a quadratic function or a parabola. Y'all have heard that word before? No? So a parabola is that quadratic U shape. Okay. So go ahead and draw yourself just a regular old parabola. This is supposed to be your parent function. Okay. Mine looks terrible, so try it again. I'm going to put x squared on the left arrowhead, okay? Now, the next one says 2 times that, 2 times x squared. Does 2x squared make it narrower or wider? Is that a vertical stretch or compression? What do you think that 2 does to it? Maybe. So 2x squared, is 2 bigger than 1 or less than 1? Okay, 2 is greater than 1. So think about if you're holding it, greater is going to do this to it. So that's a vertical what? Stretch. Bigger than 1 is going to stretch it. And if it stretches it, it's going to look, if you have like some dough in your hand and you stretch it, it gets a little narrower. Okay, so again, vertical stretch, narrower. So go ahead and draw yourself a narrower one and put 2x squared on that one. And look, I'm going to graph these over here. If I type x squared, I'll get my parent function. What button do I press to graph another graph here? everyone know that tab, you can get more than one graph. So I'm gonna hit tab, I'm gonna do 2x squared, and let's see if that's right. Y'all see the blue one and the red one? The red one is 2x squared. It looks narrower, but we call that vertically stretched, okay? So what do you think is gonna happen if it's 1/2 x squared? Vertical what? Vertical stretch was 2x squared. So 1/2 x squared is vertical, what's that word? Compression, okay? So it's gonna be, if you compress something, it's gonna look wider, okay? So go ahead and draw yourself a wider parabola and put 1/2 x squared, okay? So I know mine looks kind of ugly, but, oops. If I hit tab again and I do 1/2 x squared, it's gonna look like that black one. Okay, the red one is the original, the blue one is vertically stretched, the black one is vertically compressed, so it's gonna look wider. Okay. All right. And then let's try number 2. Go ahead and sketch your parent function on number 2, just a regular old parabola. Now, on number 2, the second one says -4, and we know f of x is x squared, so it's -4x squared. What does the negative do to the graph? What? I can't hear you. What? The negative doesn't compress it. Again, it was positive, and now it's negative, so instead of, okay, it reflects downward, right? So instead of positive going upwards, now it's negative going downwards, and then this +4 here vertically does what? What do you think? Stretch or compress? 4 is bigger than 1. It's a stretch, so it's a flip and a vertical stretch. So go ahead and draw it going down, and it's going to be a little narrower. Okay. Here's what it looks like over here. I got x squared, my original parent function, tab, -4x squared. Do y'all see the blue one to the red one? It was a little bit wider. Now it's narrower, going down because it's negative. Okay, so this is -4x squared. And then what do y'all think happens right here for -1/4? What does the 1/4 do to it? Stretch or compress? Compress, okay? Less than 1 compresses it. And since it's negative, it's going to open which way? Up or down? Okay, down. So go ahead and draw yourself a wider parabola going downward, okay? -1/4 x squared. Okay, so this black one is your -1/4 x squared. It is wider because it's less than 1. It's been vertically compressed, and it's reflected across the x-axis, okay? So all those things, let's go ahead and summarize them. So first of all, if A is negative, what happens to the graph? It what? Bless you. Again, if it's flips across or reflects across the x-axis, okay? So if A is a negative, it reflects across the x-axis. Okay. Now, if the absolute value of A, meaning forget the negative sign, just look at the number. If the number is greater than 1, okay, we say that's a vertical what? Which one? Stretch? Okay, so it's greater than 1 is a vertical stretch. And when it's vertically stretches, does it look narrower or wider? What do you think? Narrower, right? Stretching it, it's kind of getting skinnier, it's narrower. Okay, what if the absolute value of A is between 0 and 1? That means, forget the sign, just looking at the number, if it's between 0 and 1, if it's a fraction or a decimal, like a 1/2 or a 1/3, less than 1 is going to be a vertical what? Vertical compression. Okay, and what is that? When you vertically compress it, is it getting narrower or wider? What do you think? Wider looking, okay? It opens up more, so it seems, right? Everyone getting this down? We are almost done. We're gonna get through this number 1, and then we're gonna skip number 2. Okay. So that's basically the notes about A. So there's 3 things that can happen. If it's negative, it reflects. If it's greater than 1, it's a vertical stretch, which makes it narrower. If it's less than 1, like a fraction, it's a vertical compression, wider. Okay. So real quick, if it goes from x squared to 1/3 x squared, which one of these 3 is it? What happened to it? What? Okay, it got wider because it was vertically, or it was a vertical compression. Okay. Now, the graph does not have enough room to graph this stuff. Look at these numbers. There's like not enough room on this graph. Okay. So we're gonna we're gonna skip the rest of this. Okay. But the main thing, main thing is that you know the 3 things that A does. The number in front can flip it, can make it stretch and get narrow, it can make it compress and get wider. Okay, you're going to use that to do this practice. I'm going to pass it out now. Okay, so when you get it, you can begin. Let's get started.